Okay, here's our second review. And our second review is utilizing opposite operations to solve equations. Remember, in all algebraic equations, our goal is to isolate the variable or get x by itself. And in looking at question 1, in order to do that, I need to get rid of a negative 2 coefficient. And since that negative 2 coefficient is doing what operation? Multiplication. The opposite of multiplying by 2 is dividing by negative 2. So therefore, I'm going to divide both sides by negative 2. And when I do so, I isolate the variable, and my solution is positive 2. In question 2, I'm multiplying x by 5, so I'm going to divide by 5. X will be equal to negative 10 divided by 5, which is negative 2. Question 3, it says a fifth of x. Now remember, if I draw it like this, 1, 2, 3, 4, draw a fifth of x. If I was to quadruple this, if I was to quintuple this, meaning multiply it by 5, I would end up with that picture. And when we put that all together, all 5 of those will actually make a full x value if we actually put those in. So therefore, multiplying this side by 5 and multiplying this side by 5 is the opposite operation. X is isolated, and the value of x is negative 10. Question 4, dividing by negative 3, the opposite operation is multiplying by negative 3. X will equal negative 3. In question 5, we actually have a grade 4 or 5 question, because in grade 4 or 5, you might have had a box takeaway 3 equals 2. That's a grade 4 question. And then you were like, I know what the answer is, Mrs. Smith. And you said 5 is the answer. 5 takeaway 3 is 2. But that same question in grade 4 can be done in grade 9 by simply adding 3 to get rid of your constant, and x equals 5. A systematic approach to using that idea. In question 6, subtracting 2 from both sides will isolate the variable. I think in grade 4, if you said, what's 1 take away 2, your brain would have melted in grade 4. But now you're more mature and you're able to figure out that a positive 1 and a negative 2 make a negative 1, and therefore your answer is x equals negative 1. Question 7, our constant is negative 3, so adding 3 to both sides will create a 0 pair, isolating the variable x, giving you x equals 5. In question 8, we change things around. Our constant and our variable is on the right. So we do know that the constant is negative 2, so we add 2 to both sides to get x equals 9. And then we start in question 9, which is a two-step algebraic equation. In this equation, we have a constant and we have a coefficient. Can anyone tell me what the constant is in question 9? Hayden, what's the constant? Negative 1. And what's the coefficient, Hayden? It is not 2. Everybody thinks it's 2, right? Will, what's the coefficient? It is a half. Remember, this question says half of x minus 1 is negative 6. That's what that equation says. And when I read half of x, I realize that half of x is really a 0.5 or a half coefficient, right? So even though it is the number 2, it is not a 2 coefficient. So once I acknowledge that, I'm like, okay, the easiest way to get rid of the equation is to get rid of what first? The coefficient or the constant, Danny? That's right. So we're going to add 1 to both sides. Danny, your voice has changed. Negative 6 and a positive 1 makes a negative 5. Then you double both sides, because if you double a half of something, you get a whole of it. And your answer is x equals negative 10. Question 10, 2 steps. Get rid of your constant first by adding 5 to both sides. 5x equals negative 25, and a positive 5 makes negative 20. Divide both sides by 5, and x will equal negative 4. And finally, your last question on this particular, I guess it's not your last question, but two-step equation. Add 3 to both sides to get rid of your constant. Negative 2x equals negative 8. Divide both sides by the coefficient, and x will equal a positive 4. Mr. Mack, this is so easy. I know. No, it's not. What's your constant, Jack, in question 12? Constant. 3x is your constant. Are you sure? 7 it is. So you're going to subtract 7 from both sides. You got rid of it. 3x equals 12. Divide both sides by the coefficient, and x will equal a positive 4. Padme, what's the constant in question 13? Negative 1. So add 1 to both sides. 5x equals negative 15. Divide by the coefficient, and x equals negative 3. TO, what's the constant in question 14? Subtract 3 from both sides to get rid of a 3. You get negative 5x equals negative 5. Divide by the coefficient, or of the recursion, and x equals a positive 1. And I think our last two questions, is that the last? No, we go to 20, don't we? Do we go 20? 20. Constant in this equation, mitochondria, what's the constant in 15? Negative 5. So I'm going to add 5 to get rid of it through opposite operation. A negative third of x, that's how I want you to read that. I want you to read it as a negative third of x equals 21. Multiply both sides by negative 3. And x will equal negative 63. Gracie, what's the constant in question 16? Correctamundo, negative 4. So we're going to add 4 to both sides, getting rid of the constant. You have 7 equals. Now keep in mind, this is the same thing as this, which is the same thing as this, which is the same thing as this, which is the same thing as this. But given the fact that all 5 of those are the same thing, I am going to choose this one to write. And the reason why I'm going to choose that one is because I'm now going to multiply both sides by negative 2. And I'm used to seeing it that way. And I get my solution of x equals negative 14. We're on the home stretch, people. We have some distributive properties questions here. So expand and solve. Expand is a fancy mathematical idea of using your arrows for distributive property. Okay? Now I want you to keep in mind that 3 groups of x minus 5. Do you all agree that's x minus 5? Yes, you do. And if I was to triple it, or mathematically speaking, multiply it by 5, I would actually take, not take that. I would actually triple x minus 5, and I would get this. And what does that say? If I was to ask you, what does that picture say? You would say, well, it's 3x minus 15. Would you agree with that? Which you would get if you multiplied 3 by x and 3 by negative 5. So therefore, once I expand it using distributive property, that's the equation I create. Add 15 to both sides. You get 3x equals 24. Divide both sides by 2, and x equals 8. Modeling the next one doesn't work so well, but distributive property does. So if I expand it, negative 3 times x is negative 3x. Negative 3 times negative 5 is positive 15. So that's the equation I create when I expand it using distributive property. Subtract 15 or get rid of your constant by opposite operation. Negative 3x equals negative 42. Dividez-vous by the coefficient of the negative 3, and x will equal 14. Positive 14, because a negative divided by a negative is a positive. And the very last thing we have in our opposite operation test here is using division first. So what I would like you to do again is think about this here as being 4 groups of 2x minus 2. So if I actually drew 2x minus 2 and then quadrupled it, I would, hang on. If I doubled it, tripled it, and quadrupled it, or multiplied it by 4, that's what I would get. And I would have this on a scale equal to negative 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this equation here says 4 groups of 2x minus 2 is equal to or is balanced with negative 20. But the idea of division first says if 4 groups of 2x minus 2 is equal to 20, negative 20, then each group of 2x minus 2 has a weight of negative 5. Do you see that pictorially? This is what it looks like pictorially. If 4 groups of 2x minus 2 is equal to negative 20, then each group of 2x minus 2 has to be equal to negative 5. How we express that numerically looks like this. If I divide this side into 4 groups and divide this side into 4 groups, or taking this side and dividing it by 4, or taking this side and dividing it by 4, we've had enough practice now to realize that does not affect its equality. But what it does say is 2x minus 2 is equal to negative 5, right? When I divide both sides by negative, or by 4. Once we have that, we can add 2 to both sides. 2x equals negative 3. We can divide both sides by 2. And x will equal negative 1.5, right? And that's the value of x. Finally, the last one. Well, if you drew it, yes, there's a lot of work. But if you didn't draw it, if you just did the work, it's not so bad. What would I divide both sides by in 20? I'm going to divide by negative 16, right? And by dividing this side by negative 16 and dividing this side by negative 16, again, should not affect the equality of that balance. Instead of having negative 16 groups of 2x minus 7, I'm going to have one group of 2x minus 7. And 32 divided by negative 16 is negative 2. A much simpler equation to work with. Adding 7 to both sides, we'll get rid of the constant. I get 2x equals 5. Dividing both sides by 2 will give me the solution of x equals 2.5.